So we get Rohm. So who are you?
My name is Mayu Konishi, who is working at Rohm company.
What is Rohm?
Rohm is a semiconductor company which is in Kyoto, Japan.
So what does it do? Semiconductors?
Yes, semiconductors and sensors and all things.
All kinds of components?
All kinds of components.
How big is Rohm?
How big is Rohm?
How many engineers? How many employees?
何人働いてますか 3,000 people at headquarters.
3,000 in the headquarters. So what are you going to see here?
Okay, so this is healthcare corner.
So what are you showing here?
This is the point of care blood analysis system.
So blood analyzer?
Yes, this is the blood analyzer and this is a biochip for the diabetes items.
So is this on the market?
Market is quite new.
So what is new about this? What's better about this than other things?
So this is quite a new target market. So now this system is installed the clinic.
Like in a clinic, in a
Yes.
hospital?
So just a clinic market. Yes. For the especially for the diabetes
Yeah?
market.
In everywhere? In the USA and Europe? Japan? and
Now
everywhere?
we are expanding Japan and EU. So I hope we will expand to the US and China or ASEAN market.
Cool. Thank you.
Thank you very much.
Thank you.
Which other parts can you show here?
Okay, so let's go to solid hydrogen source fuel cell system corner.
Fuel cells.
Yes, fuel cell.
Nice.
Okay,
So let's see the product. Is it where? Behind there?
商品はこれですか？製品これですか？
Hi. How are you? So what are you showing here?
This is a portable fuel cell. 200 watts.
200 watts?
Yes.
So how much is 200 watts?
How much?
If you would use laptop batteries, how does it work? What is this? How does it work? Is this like a battery?
No. It's a generator.
Generator. Out of what?
Hydrogen generator.
So
This is a fuel.
is it fuel?
Fuel cell.
So where do you put this? It goes in there.
In there. This one,
Yeah.
the fuel,
Nice.
and this one is the water.
Whoa.
Water and the fuel.
So
React
how much power does it give? This.
200 watts.
So
2 hours.
how many times you can charge this?
For example, smartphone.
Yeah.
Smartphone, 40 times.
40 times.
Yes,
For a smartphone like this one.
this one 40 times.
All right. Cool. So how big is this market, fuel cells? How many people use this? Is it fuel cells is emerging technology for the future, or is already many people use it already?
We are going to sell in the near future.
Near future. Okay. Thank you. Thanks. All right. Which other things can you show?
次どこですか？
So where are we going now?
So we are going to HEM solution.
HEMS.
Yes.
How are you? So what is HEMS?
HEMS.
What is this?
What
are
is
you
it?
showing here?
Yeah, HEMS is actually home energy management system, which does that. So, one is this switch is corresponding to this two-channel switch.
Yeah.
It's Japanese, but this switch is for going out. So if you push that, then everything goes off.
Everything.
Yes, including air conditioner.
Nice.
Turns off.
The whole house.
Yes, that's right. Then when you get back, then you push this, then everything turns on again.
How does it work?
How does it work? This is actually no wire, it's wireless communication,
Wireless.
and there's no battery.
There's no battery.
No battery at
So
all.
it's magic.
Yeah, it's a kind of magic. Energy harvesting. Energy harvesting.
What do do you mean energy harvesting?
Actually, it's creating energy. That how that work is just by pushing it, LED works. So it means it is creating energies.
Microphone.
Oh,
Hold
sorry.
up. So by pushing it, the energy creates enough energy to send the signal.
That's correct.
How far?
How far? This can go like more than 100 meters.
It's RF.
It's
some kind
RF.
of,
It's actually this is 928 megahertz, sub-gigahertz actually.
sub-gigahertz.
Yeah.
And it goes to receiver.
Yeah, receiver. This is actually receiver. This USB dongle is receiver.
This is a USB dongle,
Yeah.
which you can connect where?
To
Only
this,
Only
yeah,
this?
only this at this moment. You can connect to any USB connectors, but in this case, it's connect to this one. This is home gateway. That it's translate this command to another sub-gigahertz communication, then send it to all the lights and air conditioners.
But you need to flip the switch somehow. So it means this is included, this technology inside. You put the receiver inside.
Yeah, that's right.
And
This one has a receiver also.
the receiver
Yeah,
inside.
yeah.
Receiver inside.
Yeah.
Is it possible to have a manual switch on the other end? So you just push the button. You don't need to buy a new. You don't need to buy a new this and that.
But if you want to just turn on and turn on only, then maybe you can have a button for each ones. For air conditioners, for this light, for this light, for this light. You can have so many lights. But if you do this, then let's say if you push this, then only one light.
Oh, cool.
And then if you push this one,
Yeah. Yeah.
then just you can go to bed.
Nice.
Something like that. You can program like this way.
Nice. But what I'm thinking is, if I don't want to buy a new light system and I buy a new this, is there a way to turn the switch on with the machine somehow?
If the manual is,
Add like on my home, I don't want to change anything. Only I buy this and this, not buy new light. I buy some new
yes,
mechanical switch.
yes. Of course, those two can be connected by wire. That can be done also.
Okay.
Yeah.
Cool. Okay.
But
So-
in Japan, we have a so-called EcoNet light system will be installed. So the new home appliance system will have a EcoNet light control receiver available, so that you can connect it easily.
But what I was wondering is, in my home, let's say I have a normal switch. I have a switch now. I want to add something on top, so I can use this to switch my home switch. See what I mean or not? I don't want to go inside.
Okay.
Just
so,
add something on top. But you need a motor,
but-
you need a battery. It's very difficult, I guess.
Yeah, but so if you buy this,
Yeah.
so you can send a signal. This works as a switch without changing anything.
How many
Then
people have this now at home?
at home, actually, this switch is installed to more than 40,000 buildings already
Where?
in EU.
EU.
Yep.
Which country?
Europe. It's Germany and Italy and France and
It's always the Germans that get first. It's very cool. Okay. Cool.
yes. This is installed in the how should I say a TGV
Yeah.
station
Nice.
right nearby Frankfurt Airport.
Cool.
You can control. This is done by
Over the internet.
Wi-Fi.
Wi-Fi.
But done by Wi-Fi.
Cool. Okay. Thanks a lot.
Thank you. Bye.
How much it costs the switch?
Bye. No bye.
How much is a switch like this? The price?
Price? For you maybe.
Good price?
Yeah, good price.
But I need to buy this and buy this and this and
Yeah, but so this one you can buy a lot, but this is only one. So receiver is only one. That is the key.
That's cool. It's like a kind of like a hub.
Yeah, that's right. Yeah.
Okay. Cool. Okay. What's next?
HDPLC. Okay. So then we have this is those wireless communication. So this one is wired communication, but you can use power line. So you can do just power,
Yeah.
but this is camera, right? So going this blue line, this is wired, only power line only. Then you can see the view here. No other line, only power line.
Cool.
So signal is added on the power line.
Yeah.
Then this will connect, detect those signals, then view it here.
Nice. This is smart home.
Yep,
This is Internet of Things, right?
yep.
And how big is Rohm in that field? Rohm
Ah.
is big for that.
We are getting into that. So it's new actually. Just small at this
How
moment.
big
But
it will be
how big it will be
in the next few years?
next few years? How? Like, but it's too big. But I would like to say 10%. But the IoT is very big, so it's hard to say. Yeah.
Cool. Thanks. What's next? You have more
Thanks.
stuff to show?
他に
Lapis. Okay.
Yeah.
So we are going to show you Lapis.
Yeah.
Yeah.
We are going to show you Lapis products.
The what?
Lapis products.
The Lapis is company name, and this is Bluetooth low energy. This is RF technology, but requires only low power.
So it's the Bluetooth 4.0?
Bluetooth 4.0.
It is? So how does it work? What is all these different things? What is inside?
What inside?
What is it for?
This is the module.
Yeah? And what do you do with this? This is a battery here.
Oh yeah, of course this requires a battery. これは何してるんでしょうか。はい。はい。
Sorry.
はい。
You speak English?
No.
So you can translate, right?
Okay.
Okay.
はい、
So what is this? Can you ask him? What does it do? Each of them.
はい、こちらはキーホルダーにつけていただくものでして、鍵が部屋のどこにあるかというものをお知らせするものです。
What did he say? Can you
So
translate?
this is actually key holder,
Yeah.
so that you can detect where is the key, so you can find the key easily.
Nice. So you put something on the key,
Yes.
find target.
Find target.
This is the key, so it
Oh,
finds
yeah, so
it here.
yeah.
Cool. Cool. And it's the same. All this is the same.
全部一緒ですか？
So what Lapis Semiconductor work together with Rohm, or is part
That's
of
right.
Rohm?
Actually, a group company. Lapis is a group company.
And only for Bluetooth, low energy stuff. Lapis.
Lapis does the microcontrollers, also the other RF devices also.
This is ARM CPU inside.
They are working with ARM CPU also, but they have their own.
Own. Which
Own
one?
CPU.
How does it make? Does he know? Anybody know?
マイコン得意ですか？はいはい。He's RF guy, so actually Lapis microcontroller is low power. Yeah, this one. It's a low power. It's like a low technology, like 4-bit, 16-bit, but that's the job with low power.
Nice. What is this?
Just 8-bit low power microcontroller controls all the LED light.
You have more stuff to show? I mean, can we go over here? Right. So, can you explain a little bit Rohm?
Rohm.
ロームについて私さっきやったんで、
Yeah. Explain a little bit.
Rohm.
What is role for Rohm?
Rohm.
do?
What is Rohm? Well, Rohm is basically it was we are device manufacturer and also IDM companies. But
IDM.
Integrated manufacturer, device manufacturers. But right now we have a lot of. I hope you saw a lot of R&D devices like sensors and fuel cells. And so we are acquiring a lot of other devices to explore.
So, but there's even more. So what are you going to show?
Okay, so from this portion I will introduce.
Yeah.
Here is a Rohm's analog power solution. So Rohm has a lots of the analog DC. Okay, sorry.
No, so just
Okay.
lower a little bit in your mouth.
All right.
Yeah.
So for this booth is we are showing the analog DC converter. So we have already designed a couple of the just a small DC converter like this one, and also in this day we are designing for the integrated version. So this IC management IC is for Intel platform.
So you put you put your stuff inside the Intel CPU?
No,
or no?
so Intel CPU will require the couple of the DC as an application. So we support it except for the CPU. So it means the DC or other, solution as well.
Okay. You do FPGA stuff?
Yes, FPGA is also that we have a solution here. That's why that we designed the IC and also that we are, design for the kind of the PCB board layout as well.
So my website is armdevices.net. So which ARM devices does Rohm make?
ARM device, good question. So far, I'm sorry that I don't have any idea at this moment. Sorry about that.
Okay. What is this?
So this is also the AC/DC converter, and this is the US power delivery transceiver IC. This is a really new solution. The USB power delivery is a kind of the new solution, and USB power delivery.
How much power is there in here?
How much power?
How much power?
How much?
Up to 100.
Up to 100.
What?
Yep.
No, 100 what? What?
100 amp.
Amp.
Watt? Watt. Sorry.
What?
One-
How much amp?
How much amp?
5 amp.
5 amp. Yeah, this is a profile here. So profile 5, you can see that 20 volt and 5 amp. Total the 101.
Cool. All right.
Sorry.
What's over here?
I'm sorry, I don't
No, that's good.
Okay, so this booth is showing that a hybrid MOS. So we have a IGBT and a super junction MOS FET. And also finally this year we will release a hybrid MOS. Hybrid MOS is a combined IGBT solution and super junction MOS FET solution. It means we can achieve the high current with high switching frequency.
Nice.
Maybe next booth.
Over there.
Yeah.
Okay.
よかったです。Okay.
What's it for?
Yeah, here this booth is showing that the automotive solution. We Rohm design not only for the consumer product, we also the design for the automotive solution. So here, this booth is showing that we are collaborating with Freescale CPU. So Freescale will provide us the CPU, and we are supporting the other DC or other solution, other application.
Okay. So this is ARM?
Yes, ARM is a
IMX6.
yes,
IMX6.
exactly.
Okay.
This is showing that automotive LED driver. LED driver will require the higher efficiency. That's why that we are designed for the switching regulator up and down.
All right. Cool. Thanks a lot.
Yep.
Thank you very much. Thank you.
very much.
So what is this?
Okay, this booth is showing that our wireless solution. So we became a regular member of the WPC standard. So this is showing that is wireless charging. So wireless charging is a kind of the new technology without cordless. Cordless charging is available. So far, some of the smartphone is applied for the wireless charging system. You can put there without cord. You can charge automatically. So far, this solution will be popular. You don't need to bring an AC adapter to anywhere.
How many competitors are there in making this?
Okay, so this solution is we have currently the 6 competitor, and the last month Qualcomm is also joined this member. That's why the Qualcomm is also the really
Competitor.
yeah, not a competitor, kind of partner.
Partner.
Yeah, Qualcomm is providing the CPU. Their platform will require this solution. That's why we are supporting the DC for charging solution.
So why is your solution better than the other 5?
Yeah,
or
exactly.
6?
Good question.
Why?
So that we can complete. we can complete lower temperature. So charging solution is a big demerit is the temperature issue. That's why that we design for the to achieve the lower temperature. That is a good damage, good point. And also we can charge the really productive and efficient. We can keep efficient.
Because right now with Qi, if people charge and they wake up in the morning, the phone is warm, it's hot.
Yeah,
But now with you it's better.
Yeah, better than before. That's why this WPC is discussing how we can achieve, how we can charge efficiently and productivity. That's why we will try to reduce the temperature problem or charging time problem or something.